In this tutorial, we're going to be diving deep into the world of Jit.GL.Pix, and we're going to be creating something like what you see on your screen right now. Some rotating concentric arcs which look like a kind of complex computer interface. I couldn't tell you how many times I've seen this sort of thing in movies when they want to show you that there's a massive amount of data being processed. Jit.GL.Pix is essentially a fragment shader, but it looks and feels like a gen patcher. You can find out more about fragment shaders from the links in the description below, but for now, all you need to know really is that a fragment shader is a set of instructions that are executed all at once by the GPU for every single pixel on the screen. We're also going to be writing some code using codebox, which is not really aimed at the beginners among you, but if you've never coded before, you might learn something from following along. So on a fresh patcher, I'll just create my normal setup for a Jit.GL.Pix shader. So I'll start with the toggle connected to a Jit.World, and let's call this Dervish, and let's keep it floating. Anti-aliasing with a frame rate of 30. And I'll send a texture, an HD texture, into the Jit.GL.Pix. So that's 1920 by 1080. And let's create the Jit.GL.Pix. And just for neatness sake, I'll create a Jit.GL.Layer. So we'll call it Dervish. And we'll send the output of the Pix into the layer. And I know I'm going to want some kind of counter. So we'll create a counter from the middle outlet of the Jit.World. We get a bang. And then I'll say prepend time, because time is going to be the name of our time parameter inside the Jit.GL.Pix. So I'll send that message first, and then I'll draw that texture and send it into the Jit.GL.Pix using a bang. So I'll do TBL. So the message goes first, and then we'll draw the texture. So that's the basic setup, and now we can get going with our Jit.GL.Pix. So I'll open that up, and it's down here. Okay, so first things first, I'll just create the time. So I'll create the time parameter, and I'll create an outlet. Let's just test that by saying, by making a red screen. So if I turn on the Jit.World, you should see a red, just plain red, in the window. Good. Okay. So let's start off really simple by just creating a white circle. So to do that, we'll use the snorm operator. And when we're using snorm, the center of our window has coordinates 0, 0. So if we feed that into a length operator, the length operator will return the distance of each pixel from the center. Now, if we feed that to a step operator, step 0.5, if the length is under 0.5, we'll get a 1, and if it's over 0.5, we'll get 0. Now we'll feed that to a 4-plane vector, and the 1 here is the alpha channel, and we can feed that step to the red, green and blue planes, and then we can send that out. And we get a sort of a circle, but we need to scale the y-axis up by the aspect ratio. So to do that, we can actually just we can get rid of the S norm, and we'll use a cell, and we'll times that by 2, and then subtract the resolution from the x and y axes, and then we'll divide it by the smaller of the two axes, which is the y axis. And now we get a perfectly symmetrical circle. Now let's say we want to create a ring, and to do that, it's very simple. All we need to do is subtract a smaller circle from our first bigger circle. So we can just duplicate this step and make it slightly smaller. So let's say 0.4, and we'll feed the length into that. And now we'll just need a subtraction operator, and we can take those 3 chords and stick them onto the outlet of the subtraction operator, and we minus the big circle from the smaller circle. Sorry, other way around. The smaller circle from the big circle. And we have our ring. Now, I only really want to see a section of this ring, not the full 360 degrees of it. So there's actually a really useful operator which can replace this length operator as well, and that's the catapole operator. It converts Cartesian coordinates to polar coordinates. So if we feed it an x and a y coordinate, it will return the distance from the centre, so in other words the same as the length, and the angle from the centre. So let's encapsulate this first part of our patch. We can call it gen S norm, and get rid of that length, and then we can swizz the x and the y, and feed it to the catapole operator. And when I feed the left outlet of the catapole to these two step operators, you should see the same as what we had before, that ring. Yeah, so you do. And we've also got this angle to play with. So let's say we only want to see 90 degrees of that ring. Well, let's first convert this angle to degrees. This outlet returns the angle from minus pi to pi. So first I'm going to add pi, so it's scaled from 0 to 2 pi, and then I'll divide it by 2 pi, and I'll multiply it by 360, because I find it easier to work in degrees than radians. And then I'll use a step operator, and so if this angle is less than 90 degrees, it will return a 1, and if it's over 90 degrees, it will return 0. So now we can just multiply this subtraction operator with this step operator. So there are sort of 3 conditions now going on. Cool, so we now just see the first 90 degrees of that ring. And if we change this to 180, we get a semicircle. We can change it to any number we like, between 0 and 360. So I'll just try and keep the patch tidy. I'll encapsulate this degree conversion thingy. So I'll call that gen degrees. And I'll move that down, and I'll move this across here, like that. And now I want to animate this arc. I want to rotate it around the center. And rather than rotating the actual ring, I can rotate the whole canvas. And this is quite a widely used method in fragment shaders. Now to do that, I'll actually create another cartopole object. So I'm feeding it the x and the y coordinates, and I'll send it straight back into a pole to car. So it's converted from Cartesian to polar coordinates, and then back to from polar to Cartesian. But before I do that, I'm just going to add an offset. So I'll just move this whole thing down a little bit, and I'll add time divided by 100. Oh, there we are. So now we have our rotating arc, and to increase the speed we can just make that divisor smaller. So we have it rotating like that. So now we have the basic logic behind our rotating ring, and if we take a look at the code, it's pretty simple. And if we want lots of these rotating arcs, we're probably going to want to convert all this into codebox, and this code might be quite useful if you're not that familiar with codebox. At this point, I seem to have deleted a clip where I explain how to set up codebox. All you have to do is create a codebox object and connect it to the outlet. Inside the codebox, I've declared a time parameter and set up a few variables which make it easier to tweak the characteristics of my arcs. And now you want to convert this the angle to degrees. So first we add pi, and then we divide by 2 pi, and then we multiply by 360. Okay, and now we need a sort of a final Boolean value to decide whether the color that we want passes or not. So let's create a color that we want our arc to be. Let's set it to red for the time being. So 1, 0, 0, 1. And then our output will be, so if that final Boolean is a 1, we'll output the color, and if it's not, we'll output a black, or just black pixels. Okay, so let's work on this Boolean. So first we need the step operator, and we need our large circle first. So, and we're comparing it to the length. So we have our len first, and then we can say is len smaller than the thickness plus that initial radius. And let's see if we get a large circle now. Yep, we do. So now we need to subtract the smaller circle. So we'll minus step len rad. Yep, we get the ring. And now we need to multiply all this by the angle comparator. So we're comparing the angle out of that initial cartopole operator, and we're comparing that to our arc degrees, that 270 we set up here. Oh, cool. So now we can see just 270 degrees of the arc. And now to animate the whole thing, we need to rotate the canvas. So we'll say xy equals cartopole uv.x uv.y, and then we'll say y equals y plus Let's do radians time times speed. And now we'll create two new variables, uvx and uvy, and we'll use the poll to car function and give it x and y. And then we'll say the new uv equals vec uvx uvy. Oh, need to change that for equals. And we now have our rotating arc. I want my final product to be very dynamic, and for the colors, thicknesses, radiuses, speeds to always be changing. So I'm going to need some kind of function to randomize all these variables, and let's do that every say like 20 frames. So we can do that by creating a new variable called seed, and we can say time over 20, but let's floor it. Okay, and then we'll need the actual functions. So let's create a separate function for each of the variables the main variables that we have. So let's start with the degrees. So let's create a function called random degrees, and we'll feed that the seed, and we'll just return fract, so the sign of the seed multiplied by a ridiculous number like 987. Okay, and then we'll multiply that by 360 to get degrees. Okay, so that's done. And then we'll do random thickness. And similarly, we'll do fract sign seed times 884. But I want the maximum thickness to be 0.5, or no, 0.3, let's say. So I'll times it by 0.3, and I want the minimum size to be 0.01. So we'll just say the minimum of that first part and 0.01. Actually, we'll need the max function there. Okay, and then we'll need a random. We won't use a random radius yet. We'll get a random speed. So we'll return, and we won't use the fract because we want negative speeds as well. So we'll say the sign of seed times 1023. Those are just the first numbers that came into my head. Okay. So let's say random degrees seed random thickness seed and random speed. So every 20 frames we're getting a different sort of arc. And actually I'm going to change this because I want the maximum number of degrees to be 300, let's say, yeah, 300, and the minimum number of degrees to be 10. So we'll say the max of 10 and that other bit. So now we're not getting an arc less than 10. Okay, oh, and this speed, we want that multiplied, because at the moment it's just between -1 and 1. Let's have it between -10 and 10, so multiply it by 10. Cool, so we've got a lot of variation in that circle. Just colour we haven't done yet. So I'll create another function for the colours. So I'll create a function called random colour. And we'll need a random red, a random blue, and a random green. I'm not sure why I've done it in the wrong order. Okay, let's call that fract of sine, the sine of the seed times 849, and let's copy and paste this across to the others, and then change the numbers. So 912 and 1001, and then we can pack those all into a vector. So let's say col vec rand red, rand green, and rand blue, and then the alpha of 1. And then we can return that color, and then this color down here, we can say random col seed, and now the color is changing along with all the other variables. I just need one final function, and that's going to be the function to actually draw the arc. So I'll call this function draw arc, and I need to feed it basically everything I've got. So I'll send it the coordinates, I'll send it the time, I'll send it the seed, I'll send it the arc measure, the arc degrees, the thickness, the radius, and the speed. Okay. So I'll start kind of copying and pasting everything from here into this function. Okay, so I'll start with all this. The UV is going to be the same, so I'll just copy these 4 lines. So and then I'll indent them. Okay, and I'm going to need some underscores before the UVs, and before the speed, and before the time. Okay, right. And now I can simply just copy this across. That's all the same, and then the final Boolean I can pretty much copy across. We just need to add some underscores here as well. Yep, so that's all we need for that. We can always correct it later. And then we need to set a color for this particular arc. So we'll make a variable called arc color, arc col, and that will be equal to, we'll get this to call the function random col, and we'll send that the seed. And then we'll say return. So if we'll use a ternary operator here. So final bool arc col. So if yes, then we'll return the arc color. If not, then we'll return black. And that is our function. Pretty much complete. So we're just left with this in the main body of our code box. So we can get rid of this final line, and the out1 can just call that draw arc function. So we can say draw arc, and we need to give it UV, time, seed, arc, degrees, the thickness, the radius, and the speed. And we don't need that color because the color is called within the function. Oh, I've got an error up here. What's the error? Variable arc degrees. Okay, so I've wrongly named this thing here. So it's just called arc. Okay, no errors now. If I turn on the Jit.world, right, I've got pretty much the same as what I had before. But it's all using functions now. This final part is probably the trickiest to get your head around, and it's the stage where we create lots of lines. And to do that, we're going to be using a for loop. So we'll just set up the basic for loop. If I can unlock the patcher, there we go. Okay, so I'll say for. And instead of using like I equals 0, I is less than 10, I plus plus, I'll just say for, so I'll declare my radius variable here, and I'll initialize that to the minimum radius that I want. So let's say 0.02, and we'll keep drawing lines until the radius is equal to or greater than 0.8. Okay, and then we'll increment the radius by the thickness each time we create a new arc. So we'll say plus equals thickness, and we haven't yet declared a thickness variable. So I'll need to do that in a second. And we'll also want a little gap between each arc. So I can say thickness plus 0.01. And that's the for loop basically set up. Okay, so right, I've got to create the thickness variable up here. So we'll start off with 0. Yeah, and then I can just copy this arc degrees into the for loop. And I can copy the thickness, and I can copy the speed. I don't need the radius because I've already got that in the for loop setup. And and then this UV stuff has to be above everything else. So what's this for loop going to do? Basically, it's going to add colors together. So I'm going to need a to start off with a color. Let's just so basically zeros. So that can be my well, it's the final color. So that's going to be a basically black. So 0, 0, 0, 1. And then we'll say final color plus equals, and then we'll use our draw arc function. So we'll send it UV time, we'll send it the seed, we'll send it the arc, arc degrees even. We'll send it the thickness, the radius, and the speed. And I think that's almost everything. So our out one is going to be the final color. You may notice, like, if I'm adding lots of colors, we might go above 1. So I'll probably need to clamp that. So I can say clamp the final color between 0 and 1. Okay, right, now if I turn on the Jit.World, I've got lots of rotating arcs, but they're all the same. Now that's because all these seeds are the same for each of the for loops. So I'll need to what I can use, I can just say I can multiply that by the radius, because the radius is going to be different each time. So seed times radius. So let's try that. Right. Now these are all slightly different. Got lots of variety there, and we could make it even less repeatable by multiplying it by 100 or something. Yeah, so slightly more variety like that. Something looks wrong, but I can't quite work out what it is. So we're just about done with our tutorial, but we really want some dashed lines, dashed arcs. It just looks a tiny little bit cooler. So that involves adding another conditional to our final bool variable of the draw arc function. So we'll add some more brackets and we'll multiply this by another Boolean. So we'll take the floor of the angle divided by 4 and modulo that with 2. So every other bunch of 4 degrees is coloured, and so it alternates between the colour and black. Okay, so is that equal to 0? Right. Yeah, so now we've got our dashes. Yeah, you might want to just like pause the video and have a think about how this works. Yeah, and so I hope this tutorial has been a good insight into Jit.GL.Pix and codebox. And I'll probably be doing some more of these, but in the MSP world with Jen. So yeah, thanks for watching, and I'll see you again soon. Bye.